Hello and welcome to Move Conversations. This is your host, Venkat. Today, we have as guest Mr. Kris Kosmala. He's a partner at Click and Connect, a consulting company dedicated to optimize business and technology aspects of supply chain operations and logistics the world over. So Kris has worked with shipping lines, ports, logistic providers in Asia, North America, South America, and Europe. And he has applied innovative information technology to improve efficiency of shipping and logistics operations, improve net margin contributions from operations, and to reduce the environmental impacts of the industry. So the theme of our discussion today will be digital transformation of global trade logistics, trends, challenges, and opportunities. We would like to thank our supporters, Priyo Ghosh, Gajanan Shanoy, and M.R. Shankar, and others who posted some of the questions which we are taking up today. Welcome to the show, Kris.
Thank you very much, Venkat. Looking forward to this discussion. This will be interesting.
Same here. So, the global supply chain in almost all sectors have witnessed unprecedented disruptions in the past couple of years, primarily due to the COVID pandemic and related imbalances in demand and supply in terms of raw material, in terms of components, shipping containers, truckers, and you name it, right?
Yes.
So to get it started, what's your overall view of the current situation and the likely scenarios for the next 12 months or more?
Well, 12 months.
That summarizes it.
12 months is interesting. I would say, let's look first at let's look at the first half of this year, so 2022.
Okay.
I think what you're looking for is now some sort of a reversal of the just in case ordering, right?
Mm-hmm.
So if you remember, about a year ago, maybe a little bit earlier than that, if I recall, an managing director for Maersk for North America went out publicly and saying, it's time to abandon just in time because this is just not holding very well, and it's time to start thinking of just in case. Now, this is all great to say from a perspective of the carrier, but that is not such an easy decision for supply chain managers, for people who finance inventories, for people who finance operations in the supply chain, right? Because ordering just in case suddenly means that you have to order more capacity, which may or may not be available. You may need to pay more for this, which you didn't budget for. And a lot of companies prefer to balance a contract ordering versus spot ordering for that capacity. Right. And the spot ordering is essentially expectation that the upheaval prices going up is temporary and they actually might subside. So either way, I'm hedging, right, by this correct balance between the spot and contract. And therefore, maybe some of them didn't listen, but the ones who listen and follow up the just in case, well, we find a lot of companies now in Europe and North America which are struggling with too much inventory. Why? Well, because instead of this inventory arriving in a trickle, slightly larger per packet, but trickle, now suddenly is arriving essentially in big bunches.
Right.
And it's arriving late. So suddenly I might not be able to sell it. I might not be able to warehouse it. What am I going to do with this? Either I dump it on the market, losing tremendous amount of money, or I keep it, also losing tremendous amount of money because I'm tying up operating capital in inventory. So you'll see this probably unwinding right now. But for the unwinding, what needs to happen is we need stability because supply chain managers like stability. And obviously the congestions in ports, that will take another probably 4 or 5 months to unwind. Sure. Congestions on the road, well, that's related to the availability of trailers, for instance, but it's also availability of the drivers. So it's not that easy. So maybe that is a 12-month process, right, before we unwind this. Railways, well, it depends on which economy. That's always a black horse. And of course, the ongoing management of the pandemic, that is still difficult to ascertain essentially how much delays that could introduce into the supply chains, right?
Right.
Obviously, we know in China it's all about zero COVID, like no cases. So therefore, they shut down everything very quickly. One case, and suddenly you might have a whole city or whole port affected. Some economies do it half-half, and some of them are completely open, like for instance UK. So as long as we don't have stability and the understanding of essentially what country will do if the number of cases increases, we will have a little bit of upheaval. But let's say that will be fixed over the next 6 months, right? A number of cases, the very serious tragic cases, that's just dropping. Vaccinations are now available worldwide pretty much. And companies actually now know better, the ones who are responsible for execution of the supply chain, the transporters, the logistics warehouses, and so on. They know better how to operate when the workforce calls in unexpectedly. I'm sick, right? Or no, I cannot work today because I'm afraid there is a lockdown in my area, and so on. So that's a 6 months. The 12 months, well, presumably everything will stabilize. But as you know, in supply chain, we never deal with stable situations, right? There is always some tragedy or another that's unfolding right after you finish with one tragedy, right?
Or just before you even finish one with the last one.
Yeah. So here you have a big impact of the invasion of Ukraine, right? The attack on Ukraine severed practically, or cut into half big supply chains that are flowing over railway and road from China into Europe. Okay. And they will not be able to travel to Belarus. They are not traveling through Ukraine. Everything is suddenly affected. So now European supply chain managers are probably looking at it and saying, "Oh my God, I barely finished with COVID, and now this, right?" Yeah. So that means switching from contracts that were on rail, switching to ocean, considering air. Now, okay, so the costs are predictable? Well, they are not, right? Because suddenly airspace over Russia has been closed, over Ukraine has been closed. So now you have to fly longer routes.
Longer route, yeah.
So therefore the cost per unit increases, and therefore your logistics cost that you presumably had kind of budgeted for, let's say, for air, well, that's going to be affected, right? Well, then you're going to ocean, and the ocean has its own series of problems related to ports, terminals, and the shipping lines capacity. So as you see, one problem follows another, and I think that it's very difficult to say how the second half of the year will look like. However, we probably will not be dealing with a lot of the pandemic-related issues, and we'll be looking at unwinding of the big just-in-case inventory strategies to kind of slowly return to just-in-time.
Great, that's good. So let's come to the core theme that we had set out for today's discussion. You have done so many of these digital transformation projects. The question we have is, how many of them are truly end-to-end process management, or many of them are still like kind of standalone or silo solutions?
Well, supply chain is a very long end-to-end process, right? I mean, what is the end and what is the other end? If you think about this, okay, there was a source to order, order to pay, and then the part of that follows, which is the settlements and reconciliation. So if you look at this, there are a lot of companies try to do end-to-end implementations. Mm-hmm. However, eventually, for the purpose of managing them, right, from the point of inception of the project to completion of the project, they separate them into smaller blocks.
Right.
And those blocks naturally fall into the functions rather than into all functions related to a particular process. Mm-hmm. So you might look at, let's say, revamp of logistics processes related to sourcing capacity planning and ordering, okay, rather than supply chain, which now includes warehouse optimization, the inventory optimization, sitting in those warehouses, the specific loads that you will be sending across these lines that you purchase. So, naturally, it is a big project just to revamp logistics. Now, when you think about those all other things, which consist, they link essentially the sourcing part and the distribution part. It is you will not see these kind of projects, realistically speaking, right? I mean, their cost is huge. The impact on a company, on an enterprise implementing this is huge. The providers have to adjust. So naturally, we can talk about end to end, but it's usually the smaller end to a smaller end within the larger process.
Right. So that's interesting. So let's take a step back and start with the things that help us gather a lot of rich data, the sensors, the tracking devices, and which often in common parlance are collectively called the IoT devices, Internet of Things devices, and so on. How extensive is their use in global logistics today, or global trade logistics, which you are, and our audience are? And are they in their introduction phase? Are they in their growth phase? Give us some cases that you've seen and where they are.
Okay, that's a good point. So IoTs. Listen, I mean, the big issue that decides whether you're gonna use IoTs is the cost. Right. And I still remember dealing with supply chain managers who are essentially complaining about the cost of RFID tag being at $2. Now it's at 2 cents. We can talk about broad reach and broad deployment. IoTs are not $2, and they're definitely not 2 cents, right? You're looking at devices which are probably $100 to $200 per device. Unlike RFID tag, you don't need to when you deal with RFID tags, you don't need to return them back to the source. But IoT, well, if you have it in a container, intelligently collecting all this data and telling you where it is and what's the temperature inside, was it shaken, stirred, or whatever. You actually eventually have to have your reverse logistics supply chain for these devices to actually go back to the origin, okay, to be again loaded on the new container. So you're looking probably still at very slow penetration of IoTs into the supply chains, right? So we're kind of in those early stages of RFID when it costs $2 per tag, okay? Once we're in probably in about $15, $10 per IoT device, which is intelligent piece of electronics, which does all of these things, plus the logic that talks to it and reports on it, we're probably talking about mass implementations. Now, there are certain supply chains which are very sensitive. There's the high value cargo that travels through them, right? True. And these are being addressed with IoTs. So electronics companies, the pharma companies, or traditional users, they actually want to invest in these technologies, and they're looking for the best possible tracker. Now, this tracker should be intelligent. So not just simply a passive tracker that you remove at the end of the journey to see what happened to it. Yeah. Was there some indication that the container has been opened, that the temperature has changed, and so on? Now we're looking about the intelligence, real-time intelligence. So these companies are definitely deploying this at scale. Food supply chains. Food supply chains are a little bit. They would like to do that, but it's a low margin cargo. Yes, it is a cargo that perishes. Okay, but it's a low margin cargo. So of course there is more hesitation. However, a big progress has been made in refrigerated cargo. Okay, and I think that the big step forward was the decision by Maersk to implement new reefer containers, essentially replace the entire fleet of the reefer containers with containers that are equipped with Traxens. That's a French company, Traxens IoT device, right? Right. And I still remember these early discussions where there's this discovery that suddenly instead of 8 data points, we have 800 data points from this IoT device.
Right.
What are we going to do with all that data, right? So there's maybe an issue of, well, we can do all of these things, but really, what is it that we want to do beyond these original 8 points that we had? Also, there's third-party providers. So Traxens had the advantage, of course, of being invested as well by other carriers in addition to Maersk. So that helped tremendously, right? So that means that we will be seeing deployment of these, ideally in reefer containers, because this is where the high-value perishable goods are traveling more frequently overseas. However, as the cost is dropping, other part of the supply chain, especially in foods, will be probably seeing a more broader reach of IoT devices and more broader deployments. And this is how I see it, right? But this is the moment where we are not talking $200 per device, but we are talking maybe $20 per device.
$20 per device.
Yeah, I mean, I'm speculating, but what I'm trying to say,
fair enough.
Fair enough.
It has to come down by a,
the drop in
10
cost has to
times
be
down.
really significant. Right?
1/10. Yeah. So you mentioned data points, so that brings up a specific follow-up question which we have from Mr. Shankar, who heads it up for one of the European MNCs, and he's based out of Europe. So he had a specific question: is there a data point available via IoT devices to give Scope 3 CO2 footprint by region? And that's a very specific question.
Yes. So yes. Okay. Now, I think that every case of the implementation should be driven by the understanding of what it is that I want to achieve. Okay. At what level of granularity.
Right.
So let's say if you know that each one of your container is, let's say, relates to consumption of X, of the fuels, energy, and emits Y in terms of quantity of specific chemicals, I would say, is it really important to you, or would you actually like to know at the more general, at the higher level, how much is your supply chain consuming in terms of energy and how much is emitting? So maybe rather than dealing with each individual journey of each individual container, if you're sending 100 containers a week, there's a lot of tracking over here. Maybe you should be interested about knowing what ship does it go on. So that way you can grab the emissions characteristics of that ship, use it in your calculations. For trucks, well, rather than individual truck that travels with your container, well, maybe you would like to just grab the emission standards, okay, which is the maximum allowable in the particular country or in a particular state where your container will be traversing on the truck, and just use that value rather than knowing that you managed to improve this value by 10%, right? Because the tracker had a more efficient tractor, the cab that actually sits in front of the container, right?
Right.
So, granularity and the cost of really tracking this at such a detailed level, that has to be really justified by the specific case, a specific concern. I think at this moment, my bigger concern is we still really don't have a good handle over this general, at the higher level, traceability of emissions. People are really estimating, people are guessing, but we really don't have that. Right. So should we make a leap all the way down to the container or package or pallet? Well, maybe let's just use the available sources and available technology to actually track it at that higher level. And then at some point, when situation calls for it, let's go down to the granularity of a single package.
Single package. Okay, great. So moving on to machine learning or ML. Is ML what the computers can learn from large data sets that the companies have and then leverage it? Is that a fair, simple description?
No. So with machine learning, thankfully, we're not talking about the fad, right?
Right.
If you look at the various branches of artificial intelligence, probably machine learning is probably the most prevalent right now. The reason for that is because not only the data became available in a digital format, but also we rapidly improved mathematics behind it, right? Which is the knowledge of algorithms. And we figured out better ways to process these huge quantities of data in smaller footprint of technology, which means less consumption of CPU, less consumption of energy and such, right? You know, we had optimization for last, what, 40, 50 years, right? But 50 years ago, running a serious algorithm was a question of running for weeks on a computer. That is not a question of running for a few minutes right now on a computing technology that we have available today to the masses. I'm not talking about the supercomputers.
Right.
So, you know, if you look at that whole process that we talk about in supply chain, whenever you have good historical data, and what I mean by this good, clean for the last 2 years, where you when you grab the seasonality of the occurrences, and 2 years is a minimum where you can actually say, oh, that repeats in certain patterns, right? So now I can apply appropriate algorithm to it to actually make sense out of this, trying to say, well, how will that pattern continue into the future, right?
Right.
So where have I seen it? The interesting cases is warehousing. I recall there was a customer is a big supplier of industrial components. It's about like 3 million SKUs, and they also run inventory. So it's a B2B, right? It's a wholesaler, if you will. But they run inventories for a number of their customers. Okay, and inventories in this industrial equipment really means space. So how they use machine learning is they use it to predict, essentially from the past history, predict the space requirements of the warehouses, okay, and also location of these warehouses, okay, because their customer base is pretty stable, and their expectations of this company running inventory as a third party for them is quite stable. They are able, with quite high certainty, predict essentially where the warehouses need to be geographically located, and how much capacity they need. And that is actually helpful specifically now, because instead of building the warehouses, you can actually rent capacity, right? From somebody else on a as you needed basis. So here you have a warehouse as a service, just like we have software as a service. And these prices could get lower or higher depending on how much and how long do you need that space for, right? So when you think about WeWork, it's all about estimating workforce needs, right? But here we have specific to warehousing. And applying machine learning allow them to, from memory, I think they save between 10 and 15% of costs related to the warehousing space. So they either avoided building a warehouse and decided to rent from somebody else because of the capacity calculations, or build a warehouse of certain proportions, okay, which will allow them to utilize that space better and sublease it then later to somebody else, because, you know, the predictive algorithm was saying you probably will fill up at most this warehouse to 70% if you build it to that space. Okay, and you know, we're talking weight, space, and in a cubic size, and therefore 30% will forever remain empty. So you can do actually something with it, right? So the opportunity to make additional money on your investment, okay, which is the opportunity cost calculation, right? It's suddenly improved, right? Because of this, they didn't have that knowledge before. The other space where you will see it, it's in ports and terminals. So it's a yard space demand. Just not to make it too complicated, but every terminal makes a specific agreement with a specific carrier, which lasts between 6 months and 12 months. There is a minimum quantity that is required per every call, okay, that the shipper, the carrier will discharge and will pick, right?
Correct.
What the terminals are doing is essentially they're using machine learning. So I know of 2 terminals which are using machine learning to essentially predict better,
Mhm.
okay, how much above the minimum volume the carrier will be actually bringing.
Okay.
Okay, so
Mm.
therefore you're better prepared, because what they did then use they linked it up with another interesting technology, which is robotic process automation.
Mhm.
When they saw that the prediction was that the yard would be overflowing, the RPA was launching a workflow to the customer service, which
Mhm.
would then call customers to incentivize them to pick up their containers earlier. Okay.
Right. Makes sense.
Now, this is not by giving them $100 and saying, if you come earlier, I will give you $100. But it was more like, if you wait additional 48 hours or 72 hours, our yard will be actually more congested. And therefore, your tracker, rather than spending 8 minutes inside the container terminal and maybe 40 minutes waiting, will be spending 3 hours waiting and maybe 45 minutes inside the container terminal, right? So here's your choice, right? Do you want to do you really want to suffer, or would you like to react quicker? Now that's a very intelligent use of machine learning and RPA together, right?
Right.
In the whole
Wonderful.
process.
Right.
So two good examples, right? Because they relate to big issues that we have today, which is a shortage of warehousing spaces, especially in North America, and obviously a huge overload in ports, right? Where the dwell time for the containers has increased dramatically because shippers are unable to evacuate their containers quickly, therefore not leaving room for the empties, which need to be evacuated loaded onto the ship and so on. So two big issues, and machine learning fits that problem perfectly.
That's great. So we covered warehousing, we covered port and terminal, and they do have a similarity in terms of space and the space usage and predictions, and then moving the goods in and out and so on.
And that took us already half an hour.
That's fine. So, but the other part was like, what's happening on ships and shipping, as well as container transport. Any interesting projects that you would like to highlight?
Well, the big issues of projects relate to switching from estimated time of arrival to real time of arrival, right?
Right.
Because that allows us to optimize sending my truck, my driver. That allows the terminal to behave differently. So there is a lot of projects in that space. Okay, that relates directly to the carrier efficiency, to the port efficiency, and to the utilization of the road transport, right?
Right.
You will see a lot of these projects. That's pretty much every terminal worth its money is actually working on this real-time arrival. Now this is right now based not on IoT sitting in a container,
right?
But this is more on the tracking of the vessel, so AIS, right? Tracking of the plane, so you have the corresponding GPS, and obviously tracking a truck, which is GPS, or a phone handset utilized by the driver.
Right.
So a lot of this is still kind of guessed and derived, but it's definitely better than estimated time of arrival, right? It's now we're closer to this real time of arrival. And I think that helps. Now, for this, obviously, we need infrastructure, right? So obviously, the rollouts of the 5G, the faster technologies, carrying more data, that will be all only helping in this. And at some point, with the progression of IoTs into individual package, container, pallet, we should be able to, with a great level of certainty, say where my shipment is today. At this very minute. And is the real time really real time? So I can really narrow these margins, which is quite important when you're looking at time sensitive supply chains. This is really critical, right? It's between missing the opportunity and winning the opportunities, between losing the shipment to conditions that drive it to perish versus not, and so on. So this is all golden to us.
Right. So let's take the discussion up a notch further to the trade platform level. Maersk and IBM collaborated and developed with something they branded as TradeLens platform. Now, it was supposed to be a system where suppliers, logistics players, port and terminal operators, ocean carriers, government authorities, custom brokers, name it, everybody end to end was supposed to be there. And they're all supposed to be sharing information that can be tracked, stored, actioned across the platform on the shipper's journey.
Yeah.
How successful has that been? Are parties involved really investing, cooperating in and deploying systems? You have highlighted some good use cases. You've also highlighted the challenges. So my question is, have they been able to bring in some degree of true end-to-end visibility and so on and so forth? Are going across countries, data sharing and so on?
Well, we're going back to this. What is end-to-end? It's port to port. It's port to port end-to-end, right? Because that's really what it is. Now, or is it a loading dock to unloading dock, right?
Right.
And so we can argue on this one, but I think everybody needs to understand what platforms like TradeLens is. Mm-hmm. TradeLens is the investors in TradeLens are the carriers.
Correct.
Okay. And not all carriers, because as you know, the competing carriers, some competing carriers to Maersk, set up another network called GSBN, right? The Global Supply Network Automation. So Chinese carriers use that. Maersk and MSC use TradeLens, and there are some carriers who just for the sake of it, they belong to two platforms and kind of trade with. The platforms do not talk to each other. Now, why I wanted to say this, because this platform was designed originally to benefit the carriers, to better shuffle the load, to exchange quickly information, because a lot of the vessels are kind of like hotels. Okay, there is a block of rooms for this guy, and there is a block for rooms for me, and there's a block of rooms for somebody else, and there's some block of rooms for Booking.com, and so on and so on, right?
Right.
So sometimes on a service, which is the Maersk service, you might actually have 20 other guys doing a code share, right?
Correct.
So it was really critical to have all of that information in one place, so everybody knew what travels on whose ships. Okay, that's what TradeLens is. TradeLens does also a lot of transactioning, okay, allowing collection of information that is useful to external parties. So external parties are, and not all of them, because it's subject to approval by the investors, right, which is the carriers, are allowed to use some of that data as long as that data relates to them. So you cannot just simply get the spigot open and get all your data from TradeLens only because you desire some. However, unlike the original investors, which had to put up real cash into TradeLens, okay, these logistics companies, port authorities, and so on, they actually do not have to pay, but they have to give data. So there's you pay for data in your data. And that's a big ask, right? Because that data has to be high quality, and you have to share it. You cannot say, well, that data, I'm not going to share it, but this data maybe, yes. So obviously, while this is benefiting at this moment the carriers, the other parties know only the extent to which the carriers consider it's applicable to them. So let's say, port of X, port of, let's not mention any cities, just so there is no bias here. But port of X would like to know all incoming ships coming to that port, knowing their load and knowing their time of departure from the last port before it hits this port, right? So we say, okay, no problem. Now TradeLens would say, yeah, no problem. Give me your port utilization data in exchange, and I will sort through my data and find out all of the ships that are leaving particular source, and they have the next port as your port. Okay, so you will have total visibility of all ships coming to you.
Okay.
These ships have to belong, of course, or they have to be registered inside TradeLens, right?
Correct.
So therefore, what I'm trying to say is, if you have Costco ships coming to you, let's say, well, then tough luck. Now you have to either belong to GSBN and also, pay for that privilege, and combine the data yourself, okay, which is a big ask for a lot of smaller ports, or just deal, let's say, with 70% or 60% of your traffic, which is what's coming through TradeLens, right? So here, I would say we're probably progressing to the next level of that implementation, but at this moment, that's what it is, right? So it facilitates better collaboration between the carriers, right? Which is already important. Right?
Correct.
So we have visibility. We know that containers were rolled, for instance, which means instead of traveling on ship XYZ, they were rolled on another ship, and they may be here not in 3 days, or 30 days, but they will be in 26 days. So that all of that helps, and obviously all of that increases efficiency in the supply chain.
Correct.
However, for this to be really tremendously valuable, all parties on land have to participate in it. Okay. Everybody has to have some data and contribute that data to TradeLens. So at some point, TradeLens actually becomes this huge database of enormous amounts of data. And as you know, supply chain is hugely fragmented. Even logistics provider who are somehow related to the carrier, the customs, the tracking companies, the rail companies, they are fragmented. The freight forwarders, we have thousands of those, right? Related to any particular shipment and any particular port. So to bring all of these people into all of these companies into TradeLens, that's probably a big ask. So I would say for the time being, we'll be doing with this partial usefulness, okay? But it's already better than what we had before, which is essentially nobody talking to anybody and no single place where you could actually even source the data from.
Correct. Good. So a little while ago, you briefly mentioned robotics process automation or RPA, and beyond deploying robots, there needs to be process reengineering and change management, right? Are there some good case studies on how some of these things have been deployed, especially at the man-machine interface and so on and so forth? What are the implementation challenges? Have there been some good productivity gains?
Yeah, so robotic process automation, as long as it's properly implemented and as long as it's in a process that it's very, very costly, they are very useful. And if the algorithms used in the implementation is actually the self-learning algorithms, they actually improve the efficiency as we go along. So ports are probably very, very good examples. So the implementation that you will see, like Port of Melbourne, one of the terminals in Singapore, it's the vessel transaction. So it's essentially vessel invoicing, right? You know what the vessel used in terms of port services, and at the end of the call, you would like to send them the bill. All of that essentially consists of a lot of checking a lot of the boxes on paper today, and somebody verifying that the invoice is correct and that is going to the carrier or to the owner of the vessel. And obviously, you would like to avoid the disputes, which usually come out of somebody calling you back saying, "I was invoiced for this and I never used it." Yeah. With robotic process automation, these ports essentially are reducing significantly the cost of both selecting the services that need to be invoiced and also resolution of the complaints or questions, because it's essentially done by the robot as well, right? So you send the information saying, "I don't agree with this line," and the robot is able to respond saying, "We charge you for this," and maybe provide source documentation and attach the PDF saying, "Hey, here it is, and by the way, it has your signature on it." So that's what Singapore and Melbourne have done, and I would say inside the process that you manage to automate with robots, they've seen a 50% drop in cost of operating that process. Okay. Obviously, the longer the process, the more intelligence you have to put into the algorithm, and the complexity of building it probably increases to the point that it costs way much than what you're gonna make from it. Okay. The second big issue about RPA is, it has a huge impact on headcount, because really we're saying instead of people shuffling the papers, now we have a robot shuffling the papers. And that's a big thing. If you don't have a clear idea where you're going to put people who used to check the checkboxes, okay, because it's not that easy to reallocate person to another task, then the chances are that the extent of the implementation is going to really shrink and be very small, right? So it only when it makes sense is the longer processes where the complexity is high, but the repetitiveness is also very high, then it will make sense. But it affects a lot of the workforce, which today we do it with humans. So there's a big issue between advantage of the automation versus problems that you have to deal with the motivation of your workforce, right? Being replaced essentially by a software robot.
Right. Yeah, there's a social aspect to it also, which will also come.
So that's a flag that shows up with the RPA project.
Absolutely. So another technology that has been often talked about is digital twin implementation. So have there been some good, interesting digital twin implementation in global supply chain? Because GE and others talked about it in medical devices, in jet engines and things like that, and power plants. But how has it been in a complicated supply chain logistics?
Listen, it's for digital to completely represent a supply chain, which consists of a lot of moving parts, with digital twin or digital representation. It is very, very costly.
I agree.
Okay? There's a lot of things that you have to put, and then to calibrate this and to actually see how it's learning, it's a big challenge. That's a big commitment.
Absolutely.
So unfortunately, I cannot talk. I know of some pilot projects, but I cannot talk about projects that essentially were completely successfully implemented to give digital representation of the supply chain. Now, what you will see is that first phase. So there is a lot of simulation.
Okay.
Now, what that simulation is essentially in digital twin is that I, the human, interrogate the twin, saying, based on the history of everything what you learn about my orders, my services, the stuff that I deliver, the people that I needed for it, what would happen if that happened? How the trend may potentially change, how the line actually may be up or down. So you'll see that. However, the digital twin promise is not you interrogating data, asking machine to essentially run it faster.
Right.
It's essentially the algorithm who's sitting there and interrogates itself. So you think about Google supercomputer playing a game of Go, rather than looking at all history of all previous games and learning from that. The second version essentially said, well, what if I played like this? It was never played like this before, but I have all this processing power here. I'm just going to go at it, right? So instead of playing, let's say, 20 million combinations of how to play Go, I'm going to play 20 billion combinations, some of this never heard of before. That's the reason why the second version of the computer managed to defeat the first version of the computer 5-0. Right? While the first version struggled against human player and managed to only win 5-3, I think, or something like that.
Right.
So that's what it is. That's a digital twin, where the machine is actually thinking and rethinking and playing against itself. In supply chain, as you know, that is incredibly difficult because it's very difficult to imagine, even for the machine, of what could potentially happen. Here is a war. Here is a declaration of nuclear weapons moving into adjacent country. Well, how do you evaluate all of that? It's, I probably say, okay, machine, please rest. I'll humanely look at this and saying, okay, what could potentially happen, right? So digital twin still in a stage of being desired,
right?
Okay, but probably for as long as we have these upheavals, is probably going to be used in a limited space. So digital twin for imagining warehouse space, digital twin to imagine port capacity and operational effectiveness, terminal, railway, and so on. So this very distinct pieces, but probably not the whole supply chain.
Okay, awesome. That's interesting and makes sense. Makes sense rather than some of the big bang projects goes, certain issues head on first. So the next technology we wanted to talk to you about is blockchain implementation. How has that gone in global, trade and logistics? So have there been good supply, logistics?
Well,
We have heard about the country of
sure.
origin, date of shipment, delivery, things
Yeah,
like that. But
yeah.
beyond that,
Well, TradeLens was a good implementation of blockchain, right? So here you have it.
yeah.
Yeah, food, I mean, the sourcing, right? So source assurance and then journey assurance. It is actually quite valuable. So a lot of pharmaceutical companies implemented blockchain for this.
Right.
The examples outside of pharmaceuticals, there is a Unilever, right, which has a blockchain for the tea.
Right.
So tea source and origin, and then of course what happened to it during the journey, right? So that's all assured by blockchain. DeBeers, right? So this is the
For the
diamonds.
Yeah.
That is, it's one of those critical things. So obviously there was a very interesting. It's called Tracker without E. That system that is also based on blockchain. Walmart has blockchain projects a lot around the sourcing, the truth of source, and so on.
Right.
And Alibaba has a lot of these as well.
Yes.
This is the reason
in
for
the
that
supermarket
because,
and all that you can
well,
see
supermarket
things.
is one thing, but if you remember, at some point, Alibaba was accused of facilitating resale of fake goods.
Fake goods, yeah. The other one, is the other thing that they
fake branded goods. And the implementation of the blockchain was actually used to essentially not only to eradicate this, but also to be auditable. So now you can say saying, hey, I have it in a blockchain. Okay, it has not been altered. You can check that it has not been altered, and here's the proof, right? So this is the best. But with all of these blockchain things, okay, you have to remember that once the data is in, it's assured. We know that it has been manipulated, changed, affected. There was a malicious action against it. However, what blockchain does not have is guarantee that the data that has been put in is actually real.
Correct.
Right. So as you remember, there was this big breach of Swift network by somebody injecting instructions in a branch bank, a branch in Bangladesh. Which caused massive.
And then Philippines and all sorts of things got
correct,
caught up,
and just massively, very quickly distributed. So here it is, right? The malicious action of at the data entry point, and blockchain being unable to validate, but yet assuredly transfer the money out. Right? Until a human checker said, "Wait a second, this is." There was a. I think there was a.
It's a spelling mistake.
Correct.
They said that like anyone who has been doing this won't make the spelling mistake, right?
Correct. So blockchain does not really have that validation. So for this, you need other mechanisms, right? To make sure that the data that has been entered is actually true, and it's actually not already false, because then essentially blockchain is used to facilitate exchange of false data without knowing that that's what it's doing, assuredly and very safely.
So the the malicious acts and assurance, or leads is a good segue for my follow-up question, is that in recent months and weeks, almost every week, many crypto and NFT thefts and scams have been reported. So I wanted to know, what are some of the notable security or fraud cases that that have taken place after somebody implemented a blockchain or a trade platform projects? Is anything in the public domain? That's what I'm,
I think,
because when they go to the court and things like that, then they come out in the public domain, right?
Yeah, and a lot of these things are actually solved by settlements. So essentially, you never know, right? Why I would like to share, I don't have really any examples that I know, whether through my private work or publicly available sources, where you would actually find information saying there was a fraud, right? We know that it could be broken in many ways, right?
Okay.
Either before the transaction gets injected, or after the transaction has been consumed in some ways. So the history can be essentially changed in some ways, but we don't really know to what extent that fraud is affecting us. Now, now having said that, supply chains are probably not these high value targets. I'd say cryptocurrency is a high value target, right?
Yep.
And that's where the breach happens, because I can exchange that currency for real money, right? Supply chain, well, if I manage to grab a shipment of oil, well, I have to physically accommodate this, you know, vessel to vessel transfer, you know, get to the tanks and so on. So it's, you know, it's when you have an asset or commodity, it's probably much more difficult to go for a big fraud. Okay? But in a cryptocurrency, it's easier, right? It's much easier, and it's virtually untraceable. Although I have to say, you know, there's a very recent case in the United States where they did manage to grab somebody who raided an exchange and stole, you know, something that was worth maybe 2 million, and suddenly it's worth now 200 billion.
Billion and things like that.
Or something, something outrageous amount, right? Because the value of the cryptocurrency
has gone up,
and they started selling. And because they started selling, this is what I'm trying to say, is at some point the transaction left the secret vault and became visible to the law enforcement.
Right.
That happened.
And the advantages of blockchain finally showed up, right? That hey, it's showing up.
Yes. And now I can finally trace you that was you who broke into that, right? So it's okay. But you know, for a long time, that you know, they managed to sell smaller amounts to other people, so they managed to launder some of that amount. Now imagine doing this with commodity product in a supply chain. That is much more difficult unless you have willing buyers, willing
it's much more complex. That's a different thing. It's almost like the physical kind of a thing. It's about documentation, frauds and things like that would be the first things that will probably show up, right? And things like that. And good. So the other thing that is the human aspect of all of this, you know, what jobs in the whole spectrum of global trade, supply chain, logistics, etc., are more likely to be automated? And what critical skills should young grads entering this industry acquire?
Yeah, okay. Well, thankfully, we're talking about the grads, right? So grads are, of course, not looking for a basic administrative jobs inside supply chains, logistics, execution, and such. Therefore, they will not be at risk of being replaced by the machines. But I would say if you are a worker in a warehouse, okay, a fully automated warehouses are coming our way. There's no question. Okay, these robots right now running around the warehouses are getting cheaper and cheaper. The technology to drive them is getting highly efficient right now, and it's very cheap, or it's becoming cheaper. Therefore, I would say warehouse workers, basic meaning of physical tasks, that's going away. It's just, you know, there will be this is just like the ships, right? A big container ship, we used to operate with 25 people. Now you go on a ship that is 3 times the size of the ship that was big, and you have 7 people.
Okay. Oh yes,
that's what it is, right? Because a lot of other tasks you really don't need it. Yeah, you still need the mechanics looking at, you know, down in the engine room, but you need fewer of them. On the bridge, you don't need nearly as many people as we did before. And obviously, you know, cooking, well, I can prepackage a lot of the meals. You don't even need the cook, right?
And if there are only 7 people,
and there's only seven people, and maybe a mascot dog or cat, right? So, you know, not much to feed, mouths to feed. Robotic process automation. So all of these processes that are, you know, verification of something that has been documented. I think that these jobs are going away. There's just no future in them, because the robots are much better, and they're getting pretty good at saying, oh, this box wasn't checked, should have been checked. Is it important? Is it not this subject of possible complaint or settlement talks or something like this? Machines can evaluate these now. It's rather than just simply saying check yes, no, not not visible. Signature yes, no, right? Now they're saying, well, signature no, but was it important over here, or was the initial sufficient, right? So the machine can do it right now. So a lot of these tasks are going away. If you're going into supply chains, I would say as a graduate, in addition to knowing a particular function, become interested in a particular function, but not only in that function, but also in adjacent functions. So when we're talking end to end, okay, be interested across multiple functions, because a lot of these jobs are being consolidated now into one. So somebody who is only responsible for customs documentation now might need to also deal with the security checks on the cargo, country of origin, or some other things that are probably outside of the basic validation of the customs documentation, right? So become interested in how that's being performed, what's needed to perform this thing, and so on. And also think ahead of, is this repeatable, and therefore can it be replaced with technology?
Right.
Because if it can, then you should also bring systems thinking to your job, where you can introduce improvement in a process by saying to your new manager in your new company, saying, you know what, this one we can actually automate. That's very useful, because the hiring managers, while some of them may be afraid of their jobs being replaced by automation or the stuff, actually they do not care, because their KPI is to reduce the cost.
Correct.
And therefore they can take your idea to the higher management and say, you know, there is this new guy, and kind of he's full of himself or herself, but they have an interesting idea, and that might actually help us to save money, reduce the cost, because the cost of logistics, the cost of operating, executing supply chain is still quite high inside the company, and any reduction could be used as an advantage. Either the company makes higher profit, or is able to pass it on to their customers, so therefore become more competitive by offering lower price. Right?
Correct.
Because the cost of supply chain really adds up, right? When you look at everything that goes in under the umbrella of logistics and supply chain execution and management and planning.
Right.
So this is what I said: system thinking, bring to your job. And by systems thinking, not only that, hey, the systems could be used over here where there's a number of humans, but also that's the function that they're asking me to do. What are the adjacent functions? Because if this job gets consolidated, something else, I should be the first choice for that new overseeing of that consolidated function. Right?
Absolutely. Great. So, Kris, I teach a course called Managing in a Volatile, Uncertain, Complex, and Ambiguous Context.
Oh, great.
VUCA. VUCA context, right?
You'll be busy for the foreseeable future.
Hopefully. So in that, my students do an exercise to look at various factors, social, technological, economic, ecological, political, legal, etc., and the industry trends on top of it, and try to identify what could be the VUCA challenges and opportunities a particular company can face. Now, that's what they do in their course. But my question is going to be that if an AI system starts scanning news, information, picks up important data, economic indicators, legal restrictions, travel restriction, outbreak of disease, right? The whole thing, and starts doing predictions, some convertible actions, insights, maybe prescriptive, suggestions, and so on. Could it have helped a company when the pandemic broke out and the crisis became bigger and bigger?
Yeah, well, the first one, I think this is really going back to the digital twin, right?
Because exactly, or AI in general, right? Which we didn't.
Well,
bigger AI.
Digital twin is essentially AI complex implementation, a more complex implementation, right? Because that's a deep learning rather than a machine learning.
Exactly.
Now, think about this, right? Because it just throws me back to my MBA times and the PESO framework.
Yeah, exactly.
And if you remember, the P stands for political, right?
Yes.
And this is what I'm trying to say is, a machine is only as good as the things are predictably following the course. So let's say, inflation goes up. Oh, therefore, Federal Reserve or the central bank will do this, right? That's predictable. However, the last 5 years, I would say, supply chains were not affected by the predictable things, but actually the unpredictable political behavior.
Exactly
And
why I
this is
asked this
political.
question. Right.
So you're looking at this and saying there is, I cannot, I mean, I'm a big fan of machinery, right? Because obviously applied mathematics is in my background. However, these political things, they're completely unpredictable, right?
Right.
Would you have guessed what would happen to your supply chains because Republicans elected Trump and then America elected Trump as a president? Would you have predicted the upheaval in the supply chains that are flowing between China and United States? Probably not. And there is, I hardly imagine
or how much, like you would have done in your MBA, how much of scenario planning could you have foreseen and thought through and done it, right?
Yeah. And you would have to feed this machine and the training data. I mean, we've never had president like this, and we never had a fight like that, right?
Right.
Earlier, I mean, when China was joining WTO, right, and there was a high percentage of approval for this.
Correct.
There is no machine who could have predicted actually what will happen 20 years later and how that will lead to a trade war. Now you can scan the news and the machine can probably figure out that there is a high danger of disruption of the supply chains that flow through Ukraine somehow. So China to Europe. But would it actually derive sufficient information to say, well, Belarus is a close supporter of Russia, and they will block also the access, therefore the alternative routes through Poland to the EU border. Is that feasible?
Right.
Probably not, right? So you really need human in a process, which either guides the AI or at some point just says, okay, I have enough of this guiding and training. I will just do it myself, right? With my own brains and my own understanding of the event. And our understanding of the events may not be even much better than the machine, right? Our chance of error maybe is 50%, just like the machine will err. But at least here we can blame specific person for a specific decision. I would say it's very difficult to trace the chain of responsibility back to the machine and saying, machine told me that. Therefore, that is very difficult to explain to the CFO, to the shareholders of the company, saying, well, the machine told me this, and therefore we made a decision like that. So I would say that this all of these analysis and your course should really not, I mean, the technology will be making progress, but I would say AI, there is no sufficient training data to predict that political part. So economically, where I can derive some behavior based on, although I have to say is,
in fact, political and social also, right? How would humans collectively behave, and then socioeconomic, right? That so half of them disappear, right?
But here's as I was just talking to you, I was listening to myself and thinking, well, wait a second. Machine would have never predicted that the central banks will keep the rates at near zero for so long.
Right.
No machine would predict that. The machine would say, no way. Right? And in every quarter, we were looking at 0, 0.1 or something like this. And we're suddenly saying, how long can this continue? How much debt the central banks or the economies can take? So whatever predictions we had before, on whatever assumptions we would give to the machine, saying the debt will never cross this border, well, that has been all along crossed, right? So the value of the machine is there. Okay, but I would say in your course, in that specific course, the unpredictability will still require
humans, right, to think through. So which means they can use these learnings in the future still, right?
Correct. But that goes back to who do you need to be if you're graduating and you're going into this business? You need to have that systems thinking, connecting the dots when sometimes there is no obvious connection, because the machine will not do it for you. So if you rely on the machine to tell you what the possible solution prediction is, you may be in deep trouble very quickly, right? So that systems thinking is critical. If you're just looking at your function, if you're just looking at one event, and you think, okay, well, that's easy to fix, or maybe it's more difficult to fix, but I know the fix. Well, in assistant thinking, you know that the number of variables dramatically increases number of possible outcomes. So yeah, using the machine to go quickly through the outcomes that are probably not feasible, okay? But then concentrate on a number of cases that the machine says they're plausible, they may happen, and then you determine essentially which plausible outcome will actually the most likely affect you, right?
Right. So human and machine, man and machine.
Yes, but learn how to use it.
Yeah.
Rather than just simply say, well, the machine is there and it will spit out this and that, the dashboard, the report, this and that. Learn to evaluate this critically. And in MBA, there is quite a bit of that critical thinking, right? Especially if the MBA courses are structured around cases rather than theories and frameworks. And I would say your course has to insist on that, a combination of case work to actually understand how to use that technology best, because it's there. So why not, right? But at the same time, you have to critically think as well, because you'll be called to action to choose, instead of choosing out of 500 scenarios, you might need to have 5 final scenarios where you will have to make a decision, not the machine, right?
Correct. Fascinating discussion, Kris. Thanks a lot. I could go on, and you're full of information and real life experiences in this. Thanks for sharing with us. Thoroughly enjoyed discussing.
It was absolutely a pleasure, and sorry to running over slightly, but
no. I don't think that's not the thing. I think it's very important that we all our people get the right deeper understanding of the issues, and that is more important. So that's what differentiates this interview from any of the news channels thing where they have a time bound restrictions. That's why we call it conversations.
Pleasure. Thank you.
Thank you for joining us in yet another episode of Move Conversations. Hope you enjoyed this episode. Please subscribe to the Move Conversations YouTube channel and press the bell icon to get notifications of new episodes. Thank you very much. Till I see you in the next episode. Thank you very much. Have a great day.